Yes, thank you. And thank you very much for inviting me here. So that's my first time here, so I'm a newcomer compared to the talk you had before. So I would like to tell you a little bit about what we do, which is finding black holes with lasers. So I found this fantastic image, but this is obviously not how we do it. Does anybody know what this image shows? What kind of laser you see here? Red. The red laser, yes, but what it is for. So what's the purpose of shooting this laser into the sky here? Second? Nope. Okay, I should have brought my Astronomy 101 talk as well. So this is not what I will tell you about, but this is a guide star laser. You probably have heard about this. So you shoot an artificial star into the sky to help an adaptive optic system to calculate away distortions. So this is an ordinary telescope sitting somewhere there, but it wants to have some defined point in the sky that it knows where it is and how it looks like to calculate away distortions. So yeah, you heard astronomy already, so my talk will be about astronomy. And I think you know how astronomy looks like. People getting their telescopes out, and then you look at the stars. No, that's astronomy. Yeah, kind of, but actually, if you do astronomy nowadays, it looks a little bit different. So this is just one example. Again, something you heard of maybe. SKA is a big telescope project that's just been started where the UK is involved in, but it will be located in South Africa and or Australia. And these are just 2 or 3 or 4 test antennas. So this will be a huge array of antennas looking like this, radio telescopes. So seeing not optical in terms of normal camera waves, but radio waves and making images from it. But the point is, they're huge machines, and the actual observer sits somewhere else at a computer, so probably here in the UK. And that is what we call big science, very much like the particle accelerators. You need a lot of people, a lot of machines, and then you sit somewhere in a computer pressing buttons. And I would like to tell you about another big machine where people sit elsewhere pressing buttons, doing astronomy, and of which you probably have not heard before. And this is one of these. This particular one is called LIGO. And that's an acronym, stands for LIGO, Laser Interferometer Gravitational Wave Observatory. So the actual title of my talk should be gravitational waves. So I would like to tell you about what gravitational waves are and how we detect them and why we do this, when we do this. But actually, I will tell this as a little bit of a personal story, so a little bit how I worked in this field as a student, how I work there now, and what my students do, so that I hope I can tell you 2 things at the end. That this big science is a very slow process. So you can't just have everything, invented by a genius into 2 years and then everything's there. But actually, as a physics student, you can have a big impact on what's happening already. So it's probably the things I find the most surprising myself, and I know that most students don't understand this before, that you can have an impact, but it takes 30 years. Okay, that will be my story. So let's start with gravitational waves. So most people have not heard of those things. So what are gravitational waves? The reason we want to look for them looks like this. And this is how the university mostly looks like. You know what I mean by that? 96% of the universe is dark. So we know from measurements that there is stuff out there, and we can see some of it, stars and some planets and so on. But we know that from the energy and mass we can kind of assume in the universe to make everything look as it should look like, we know that 96% of the universe is dark, meaning we can't see it. And the only way we typically see things is by looking with a telescope. So if it's dark, we can't see, we don't know actually what it is. So that is the reason we want to try to measure something else. One of these something else's is called gravitational waves. And here's just a kind of buzzword summary I usually give in a science seminar. So what are gravitational waves? I will explain this all in a few slides afterwards. So first of all, they are predictions. So that's a theory. Somebody had an idea that these things should exist. And the someone was Einstein when he wrote his theory for gravity. And out came gravitational waves as one of these predictions. And then what this actually kind of means, you try to make a picture of it, and the picture we come up with is those are ripples in space and time. The other thing is we want to do astronomy with it, so what produces these ripples in space and time? Well, heavy objects that are accelerated. So you need a lot of mass, and they have to move very quickly. So that could be, for example, black holes or other cosmological objects. And yeah, so this is all a little bit complicated. Let's try to see whether we can explain this a bit better. So this is a photo of how we tried to explain it during our outreach session and so on, where the idea of
space and time of something that can stretch and that can have ripples is a little bit visualized. So the idea to understand it is to see space and time as a rubber sheet, where